Okay, now we have functions, and the instructions have changed to where we're finding the roots. And what this means is that you're going to want to set things equal to 0, because what you remember from previous chapters is that, depending on what graph you have, these are the zeros, where y is equal to 0, and that's the same as saying f of x is equal to 0. So if we want to know the zeros and solve these for when y is 0, then we're just going to change that. So let's rewrite the whole problem even as f of x is equal to x squared minus x minus 12 all over x minus 2. And then when I go to rewrite this, the next thing I'm going to do is I'm going to substitute in 0 for y. And I'll just rewrite everything. I'm not going to factor this yet, because it's like I'm just staging my problem. But I can multiply both sides by x minus 2. And the nice thing about this is that anything times 0 stays 0. And then these will, of course, cancel out. So that the only thing that remains on the right side is x squared minus x minus 12. And before we start jumping to the quadratic formula or anything like that, let's just rewrite 0 and see if we can find factors of negative 12 that add up to negative 1. For me, that would be x minus 4 times x plus 3. And that, of course, means that x can be either 3 if it's a negative or 4. Now later on you'll have to check these, because at this function there would be a hole where x is equal to 2. So later on we'll have to make sure that there's no extra solutions that really won't work. Problem 2. Same deal as before. Let's write f of x equals x squared plus 3x minus 18 is equal to, over x minus 3. Replacing f of x with 0, we'll have 0 is equal to x squared plus 3x minus 18 over x minus 3. And I would like to see that as a step, because it's really just showing what you're doing. Just like before, we're going to multiply both sides by x minus 3. And then I'll have 0 is equal to x squared plus 3x minus 18. Looking for the factors of negative 18 that add up to positive 3, and so that would be positive 6 and a negative 3, which means that x can be either 3 or negative 6. But if I look up at this equation, can x be 3? It cannot, so we'd have to get rid of this solution and just simply say x is negative 6. Make problem 3. Actually, that has two things going on in it, so it looks different, but we'll do this one together. Rewrite the whole problem. F of x equals x squared plus 6x plus 8 over x squared plus x minus 2. And just like before, we'd set this equal to 0. Now I'm curious to see if anything can factor right now. What are the factors of x and x plus 4, x plus 2? And then the denominator would have factors of negative 2 that add up to 1. X plus 2, x minus 1. Now you actually could have multiplied this whole thing by x squared plus x minus 2 and not even worried about it. But I thought that maybe by factoring this would save us some time. So x plus 2 cancels out, so that I have 0 is equal to x plus 4 over x minus 1. And the nice thing about that is I did end up saving myself a little bit of trouble And it's, in my opinion, always a nice thing to kind of plan ahead with these problems. Here's 0 equals x plus 4, and I'll say x is negative 4. Okay. We'll save these work problems for a different video. So for now, we'll stop this one, and it'll be a short one.